Josh Miller. Campbell's with me as well. Campbell, how you doing, buddy?
Good.
Cool. Got episode 400 today of the show. Not entirely of KidzCode, but episode 400. We've done, you and I together have combined together to do 400 episodes. So yeah, looks like we're pretty chill about all that. I think we go with
What happened last time?
Can you show us, Campbell?
Yes, I can.
Let's switch over to your machine. Take a look over there. There's Campbell's machine. Starting up Unity. We were
working on estimating the volume of a cone.
Right.
Using slices, individual cylinders, and stacking them up and making them get smaller and smaller as they went up. So this is the end result.
Kind of cool. And
so as we start to get more slices, this number gets closer and closer to this number, to the real volume. So, and then if we hold down Control, it goes up by 10, the number, or by 20, I think.
The number of slices.
Sorry, yeah, by 10, the number of slices does. And then if we do Control Shift, it goes up by 100.
Yeah, it's kind of cool because it kind of gives you an ability to explore an idea that we really couldn't explore in the real world, I think. Practically, it'd be very difficult to explore this. It would take a long time to, add up all the totals. But this is a thing that software is really good for.
Yeah. And then we also finished another project. I think this was the show before last show. And it was estimating sphere volume.
Estimating the volume of the sphere.
Which is super similar to this. We're using slices to try to calculate the volume of a sphere.
Yeah. It's interesting. In both of these, we needed to use some math that we've kind of already learned to figure out what the diameter of each cylinder is at each point.
Yeah, so this is what this one looks like.
Do you remember what we used to figure out the diameter here?
Yeah, it was Pythagorean's theorem.
Right, and then the other one, what did we use?
The other one, what we used was, I want to say integrals, but I know that was just a suggestion.
Yeah, no, that was definitely not integrals. It was something you already learned. It was a polynomial equation.
Y equals mx plus b?
Y equals mx plus b. That's what it was. Do you know what degree that is? What degree
That's
polynomial?
The first degree, right?
It is. It's a first degree because x is raised to the first power. That's what we used on that. Let me switch back over to my machine. I'll show you the picture. So we're looking at the cone from the side here, and we need to figure out the diameter. Well, that's a line, and we know what the b-intercept is. It's the height, and we know the m, which is rise over run, which is basically the height of the cone divided by the radius of the cone. So y equals mx plus b we use to figure out the radius. So kind of interesting that, math that we learned already and that we've, been exploring had actual real applications in two different volume estimating approaches. One for a sphere.
And one for a cone.
One for a cone, yeah. I'm not sure if I have the math in here for the, here it is right here. Here's where we were using Pythagorean's theorem to figure out what point over here, so that we could figure out this height. We need to figure out this height. We knew the radius was always the same. So we use Pythagorean's theorem that allows me to figure out what this is, right, if I know what my x is. So as my x goes from here to here, I can calculate it using Pythagorean's theorem. Super useful. Today, we're going to do something that looks a little bit like that.
We are going to be modeling a bunch of planets, basically, and seeing how they orbit and interact.
Yeah, we'll maybe get to just at the first step is we'll get the scale.
Yes.
And we'll be able to do side-by-side comparisons of scale of any planets, maybe all the planets. Maybe we, imagine a tabletop surface and we just set the planets next to each other on the table so we can look at them close together.
Mm-hmm.
That's what I'm thinking. So let's start a new Unity project. Should we do that?
Okay. So,
solar system model. And before the show, I got some textures for
Yes.
planets and moons, and I shared them via Dropbox link to Campbell.
yes. I'll open them right now.
You can maybe drag them on screen so we can take a look at them.
Yeah.
We've never done this before, so we're gonna figure out how to wrap a texture around a sphere. I'm assuming it'll be, pretty simple in Unity. We just don't know how to do it. I've got a couple things in here. I've got a specular map. I've got a normal map. My understanding of these is limited. I know they're used in modeling, and they help create more realistic looking images with shadows and things like that when the light hits the object. That's about all I know about those. There you can see it kind of gets a sense of the texture and the shape on those two pieces right there. Those are both TIFF files. They have the extension TIFF. The rest, I think, are all JPEGs. If you look at the JPEGs, I've got a nighttime map of Earth. I've got
This is
Earth's
the
moon,
moon,
right? A number
Jupiter.
of things here. Jupiter.
Mars,
So that's what we're going to do. We're going to model this. I think we start with Earth.
the Saturn rings.
Why not? And I think what we should also consider, I think it's fair to consider this. I think we make one unit be what is the question? Well, I need to get some dimensions of the planets up here, which I don't have. I'm going to do that right now. Let's see, planet statistics is what I'm searching for here. What'd you say, Gil?
How are we going to overlap, like, for example, this material with this one?
We're going to create, so my idea on that was to create, so there's two things where we have some clouds or some atmosphere. There's two planets. One is Earth, and the other one I think is Venus.
Venus, yeah.
Right? And what I was imagining with both of those is we create a secondary sphere outside the original. We map the clouds or the atmosphere onto that. And what do you want to say? Do you want to complete what my idea is? We make it
Parented to it, and then make it a bit more transparent, right?
Yeah, that's exactly what I was going to suggest.
So, for example, we would do this one, and then on top of it, maybe this one.
Right. Now, the normal map, though, that's out there, we might find a way of connecting the normal and setting that in. That's like a thing that we'll have to figure out.
This one, wait, I don't really see this.
Look carefully and you can see kind of a depth, a sense of depth.
A little bit. So this is just kind of depth. So we might, I don't know.
So this will impact you if you've got light coming from a particular angle. That's my understanding is what this will do. This is not super necessary. We're going to be far enough away from the planets. I don't think it's going to matter. But I threw everything in there because I downloaded it.
Why not?
Over here, we're looking at a table of planetary statistics. That's what we're looking at. Kind of cool. We want to use some of this. Now, here's the deal. In terms of modeling scale, we want to look at the diameter here. And we want to kind of try to figure out what we want to do with this. Look at these numbers here. I got 4,000 for Mercury. I got 12,756 for Earth, kilometers. What if, let's right now create an Earth just in Unity. Just drop a sphere in. And let's set its scale to 12,756. Let's switch back over to your machine here while you do that. And let's just see how far we have to move the camera back to be able to look at that.
Sphere, sorry, what did you say you wanted the scale?
Set the scale to 12,756. 56. I'm not sure if using a comma, if we'll understand the comma in there. Get rid of those, the two zeros there in the middle.
Oopsies, I did not mean to put those.
Yeah. Control A to select all, Control C.
Control A, Control C.
Yeah. It looks like it's giant. We're gonna be enveloped inside of this thing.
Control B.
Okay, so there's the Earth and we're inside of it. Can we move the camera back? Go to the camera. Just
Yeah,
click on main
in
camera.
1 second. This is the easiest way to do it. I think scroll back on this one.
I'm just thinking you might be doing that a long time. Click on main camera. Oh, there it is, right there. Cool. So now there's the Earth.
And the magic button. Okay.
Nice.
Control Shift. Oh wait, we have to have the camera selected. F. It's weird. Control Shift F.
Now,
What? That's not working.
I'm just looking back over here on my sheet while Ken was looking at that. I'm not seeing data for the sun. Where's my sun data?
It's not working.
What's not working, Ken? What are you trying to do?
Control Shift F. I'm trying to move the camera to here, to what I'm seeing in the scene view.
Try it in here now. Try it with the scene having focus. I think you have to click on the scene tab, maybe. The scene tab.
Wait, I'm just trying to get at least. Oopsies, wait, that
I
was
think you're close. Try adjusting the Y, the green. I think you're just looking left or
this
right
one?
of it. Yeah. the
Oopsies,
other way.
wait, let me just Control Z,
You
Z,
can turn it around. Wait, go back. Okay, yeah, go. Okay, now it looks like you're looking at me. Now turn the camera around the other way. Right there, stop. So right there, you should be able to see it. Based on what I'm seeing. Oh, you know what? I know
Oh,
what it is.
me too. It's the camera is too far away from it,
Yeah.
so we have to turn on the far plane. I think.
Exactly. That's
What was
exactly it. Right there, see your far clipping plane? It's down a little bit more. There it is right there. Clipping plane. Down a little more. Down a little more. There.
Aha.
It's 1,000. Okay. And your near could be 1,000. And your far could be like 10, 20,000 maybe. 200,000 I mean. 100,000, 200,000. There you go. Good job. Yeah.
No, let me just.
So that's if we want to see the Earth.
Oh God! What about the sun?
Yeah. Let's get on the
No,
sun
I don't
here. I
wanna
want to
move
figure out what's
this.
going on with the sun. I want to see if I can find some stats with the sun here. What is my... Come on, sun. Where's your stats? I'm seeing some temp stats, but I'm not seeing the
Oh my God!
the diameter in here. Wait, how big is the sun? There we go. Put it on a different page. Okay, the sun is oh, it's in, here we go. 1,391,980 kilometers.
Uh-oh.
So let's now create the sun.
Sphere. Oh, I should probably give these names.
Yeah, let's rename that. Georgia SMCR is now following. Thanks for that follow.
Thank you.
Here comes the sun.
Here comes the sun.
I think we're going to be back on the camera.
Mm.
That's what I think. I'll give you that number when you're ready to do it. You ready?
What is it?
It is 1,391,980. Perfect. Copy that. Control A to copy. Control A to select all, and then Control C to copy and tap paste paste. Okay. I think we're outside of that pretty clearly.
Let me just.
We're going to need to move it too as well. There
Oh
it is right
no!
there. There's the sun.
It's so much bigger than Earth.
It is. We need to...
Wait, where is it, Earth? I don't think we
you're
can
moving
see
your
Earth. from
camera
here.
around. I don't think you're actually moving. There, it's inside of it, I think. Because its position is about close to 0. See its position over there? It's, even though it's 1,000, negative 2,000, it's about 0 because of how big it is. Do you see what I'm saying? So you're going to have to take that position and move it off to the side. That I don't think move. Oh wait.
Wait, sorry. What are you saying?
Yeah, there you go. There you go. Now move it. Hold on. It is recommended bringing the world coordinates of the game object within a similar range. You gotta do the floating point precision limitations. Recommended to bring the world coordinates of the game object in a similar range. Put this down. All right, I have a new idea on this. Because of the floating point error that we got, I would like to go in and change the dimension of these. We're gonna have to move our camera in. Okay? So here's what I want to do. Can I grab your screen for a second?
Yep.
All right. So what I'm going to do is I'm going to put a decimal point for 1,000. Okay. So for every one, that means it's 1,000 kilometers. Okay. So I'm going to do that there. I'm just dividing these numbers by 1,000. So what that means is 1 unit is 1,000 kilometers.
Yes. Okay.
There's our sun. Go back to the Earth, and we're going to do the same thing. So the Earth, if I divide by 1,000, is going to be 12.756, like that. Okay, now with those two, so there's my Earth down there, and I think we got problems with the camera again. My near plane clipping, I'm just going to set it to 0. And far plane, I'm going to divide this by 1,000 as well. Does that make sense?
Yes.
I got 3 zeros. And now let's see if we can find stuff here.
If we double click on it, it should be able to bring us to it.
Camera closer?
Yes.
All right, cool.
Wait, where's the sun?
What was the shortcut you said? Control
Shift F.
Huh, it moved away to match this almost, it felt like. This moved away. When I hit Control Shift F, I died.
Weird.
What is the...
Game object, and then if you, oh wait, you didn't have the main camera selected. So if you go to
oh, there it is.
Yes.
Make main camera selected. Got it.
No wait, I think we have to move the sun back.
Let's go find the sun.
I think it's super far away.
Yeah, can you get it? Move it close.
Yeah, one sec. That's the fast way to do this.
What'd you copy?
I copied the transform, and then I'm going to paste it in here and then just move it accordingly.
Wait, well, okay, you can, but then you lose your scale.
Oh.
All right, we'll give you the scale again then.
No, I got it.
Listen! Oh, bot's dead. The bot is dead. Let me see.
No.
My fault. Let me get that going. Sorry about that. The bot is becoming alive here. Sorry about that, Pudding.
Ah!
Say something now, Pudding. Hey, Pudding. See if we get your sensor. There it is. Good job, Campbell. Big Poggies. How are you doing, Pudding? Welcome. Modeling you from the sun. Now I can say KidzCode. You're great. That's excellent. I'm glad you're great, Pudding. Glad you're with us. Campbell is, let me switch back to Campbell's machine over here.
Okay, I'm done.
Tell me what you're doing, Campbell.
Just copying one by one the position. Now I have to move the sun out of the way.
I think we're inside the sun.
Oh.
There it is.
Oh, sun's still pretty big.
So let's move it though, side by side. Yeah, there it is, there it is, there it is, right there.
Okay.
There it is. That's Earth to Sun ratio right there.
Earth is so small.
It almost looks smaller than it should be. Let's double check the
It's like
scale
but a
on,
pixel.
On both of these. What'd you say?
It's like a pixel.
Yeah, it is. It's all planets are rounded to here. Wait, what did it say? Could I suggest to make an external file that contains all the planet information? You totally could suggest that, Pudding. I considered starting that today, doing it that way, but I felt like the additional overhead of managing the file would oh, we got a Coding Gorilla. I think your microphone is off.
Mine?
Does not appear to be off. Check.
Check.
No, yours is good. Mine may be low though. How does that now, Coding Gorilla? Any better? I'm showing a signal. Got settings showing I'm setting something out. It is a little bit out though. I can put it in a little bit. And yeah, this is kind of going all over the place. Yep, it sounded like we were hearing you from Campbell's mic, but better now. Okay, good. Sorry about that. Mic adjustment, kids, but thanks so much for letting us know. All right, back over to Campbell's machine. I wanted to double check the dimensions of the planets. Where are the planets? I just had them up. The table was up on my machine. We find that. That's the sun. So here they are right here. Okay, so we're dividing, we're basically, when we see a comma here, we're replacing that with a dot. So yeah, 12.756.
And then the sun?
And the sun, also let's look at, just confirm Campbell's got, click back on Earth over there. So anyway, kind of answer your suggestion. Wait, go to Earth first. I'm expecting it to be 12.756
yes,
in
but
diameter.
look, on the sun, we did do something wrong.
Are you sure?
The decimal should be here.
Wait. Let's see what the number is on my machine here.
Okay.
Hold on. We were like, what? How big is the sun? Where was it? It's not here. Solar system. Down. Really? I think there was a sun. How was it so hard to get to this? Sun and the sun. There we go. The sun. And then down here is how big is the sun. I had to click to get to it. Finally. Okay. So yeah, it's 1,391.98.
So it should be 1,000.
No.
Or 139.
I'm telling you what the number should be. It should be 1,391.98. You have the correct number there. You're looking at the actual ratio of the two. When they say you can fit 100 Earths, I think they're talking about the diameter across. That's what they're talking about.
Oh, yeah.
So that's how big the Earth is compared to the sun.
And the Earth is unimaginably big in the first place.
Yeah. And sorry, didn't think I finished mentioning this to you. The reason I have not gone with an external file yet is what I want to do is I think ultimately we're gonna handle this in code, and later we might refactor, get it out in another place. That's kind of what I'm thinking. If we switch over to my machine, by the way, Campbell, take a look at my machine over here. Look at this picture right down here. There's that comparison right there. There's the sun, there's the Earth. See it? So it actually looks really good. And there's Jupiter right there.
And Jupiter is that you can actually kind of see it.
Yeah, you want to throw a Jupiter in there?
Sure.
It's going to be 142.8. That's what we're going to do for its width, for its scale. So yeah, I totally hear you. It makes sense to do that. And I was thinking about loading up all the images. So we just put images out in a data file and we run it, and then we get our universe created.
So scale is?
Scale is 142.8. So that's in thousands of kilometers right there. It looks like you got a letter A after that. Control A is selects all. You're doing Control?
Oh wait, I'm doing Shift A.
Yeah, do Control. Copy. And the thing is, you never have to, you just hold the Control key down and hit AC and then Tab. There you go. All right, so now we got that. There it is. Jupiter.
And move this a bit.
Yeah, you try and put those where you want to put them.
It's crazy.
So now let's. So that's Jupiter. If you want to switch back to my machine, you can kind of look at the scale here. That's about close to what they've got here in terms of the scale. I think ours is bigger than theirs. Right here, I think their Jupiter looks a little smaller.
Yeah, because I think their sun is also a bit smaller.
Oh, okay, maybe that's why. All right, yeah, maybe you're right. Okay, cool. So now that we've got that, let's see if we can figure out how to wrap a texture around it.
Okie dokie.
1 second. Along with you. What?
Tell me what you're doing.
It's not working.
Tell me what you're trying to do so I understand.
I'm trying to move the main camera to the scene, what the scene view is. and it's not working.
And when you say it's not working, is it a shortcut that's not working? Or?
Yes, it's the shortcut, and when I try to do game object on with view, it doesn't work either.
Is it our clipping distance?
Oh, probably.
Make it 2,000. Set a 0.
Yeah,
Clipping
it
distance.
was. Wait.
So it is working. It just was the clipping distance wasn't allowing us to see it. Okay.
Okie dokie.
All right. Let's try to grab the sun and see what we can figure out about. I guess we have to add maybe a material, is my guess.
First, I think what we have to do is import new asset.
Oh.
And then, where is it?
Downloads maybe.
Planet textures. Should I just import the whole
Yeah.
folder?
Yeah. Try that. Can you do it? Import a folder. Nothing's happening. Looks like you have to. Oh, it's zip file. Hold on. Right-click that file and choose Extract All. And that's fine. It'll put it in the Downloads Planet Textures folder. Good. Now you've got a folder right next to it. Look to your left. See the folder?
This one?
Yeah. Open that up. There you go. Now select. You can shift-click. Click on the first one and shift-click on the last one. And that'll open them all up.
Here, wait.
All right, that seems to be cool. Nice. I like the organizational approach here. Planet textures. Something like that. Yeah, so putting a suggestion, creating a small data file that has the data we want for the planets, the name of the planet, its texture maybe even, and its dimensions, and then using that, it automatically builds it.
It looks like it didn't import all of them. I don't see Mercury on here. Oh wait, no. I
Yeah,
do.
there it is. It's in the middle. Yeah, the radius and link to texture. Yeah, exactly. So suggesting that, I think it's a good idea too. I'm just like, I'm just not sure the best approach to doing
it was
it yet.
that easy.
You just dragged it up onto it?
Yeah.
And that was the sun you dragged to the sun?
Yeah.
All right.
Huh?
I wonder if we can make the sun like emit light. So instead of
You can.
no shadows, it says receive shadows over here on the right, up here. Yeah, maybe turn off receive shadows. Cast shadows off as well.
I know there's a way.
I would expect those to have changed the sun.
Me too, but
It's a, yeah, distance from the sun and orbiting speed. Yeah, no, exactly. I'm thinking about all of those things there. Emission, yeah, that feels right.
color.
What is going on? Make it white instead? I don't know. Okay, interesting. Okay. Well, it's still rendering shadows on itself, which I don't understand. Global illumination. What's next to global
I
illumination?
tried it. That doesn't do.
Doesn't do anything? All right.
I'm trying to get the right color on this, but oopsies, nope, that's definitely.
Wait, there's a shader up at the top. It says standard. What's going on with that?
I'm not sure.
I don't know what those are. That's interesting. I was expecting there to be a none option there, but no.
It might be a shader.
What about rendering mode? Is there anything other than opaque or transparent that we could maybe throw at it?
I think there is.
That's getting better, but it's still looking like this weird shadow thing.
Like we want it to illuminate in all directions.
Kind of, yeah. We just don't want it to. There's no shadows on this thing. We actually want it to be a point of light as well. We want to throw a light inside of the sun. Is what we want to do.
Okay.
Can I try it? Can I just
Wait,
look?
can I just do something like light? We want just an area light, right?
No, I think it's a point light. And I think it's in the center of the sun. We might, for example, align the sun at transform position 0, 0, 0, and everything else will position at its actual distance from the sun.
Okay. So position 0 tab 0.
We can certainly take that light and parent it to the sun. Have the sun be its parent.
Yeah, I think it's an area light.
You think so?
Wait, that's not what I wanted to do.
I think an area light, when I imagine what those words mean, I think of that as, you know, kind of a light that's spreading all over. And the sun is kind of the light's coming from me, is kind of what's happening. And at a great distance, it looks more like a point.
I thought that a point light meant it would mean like it shines on one point, but that might be a spotlight.
No, I think that's directional light up above it. Is what I think. I think a point light is just a single point that emits light from it, is what I think.
Okay.
But I don't know for sure.
We'll try it.
But if you throw it inside of the sun,
I did.
and now we want its range to be like, what's the farthest distance from the sun? Let's go look at the planets and see whatever that farthest distance is. The average distance from sun.
And fade.
What'd you say?
Fade and cutout are two rendering modes.
Okay, so here's the deal. For the light to reach Neptune, it's going to be 4,496,000. It's going to have to be at least 5 million. The range of the light.
Are we not including all the dwarf planets?
Greetings from Ukraine. Visiting you from C# Fritz. Apricot, welcome. We are working on modeling the solar system in Unity is what we're doing. We haven't written any C# code, but we expect to be able to do that. Do you see what you were? I was talking about the distance, the light range, the point light. Here, can I grab it a second? So here, the range, I'm assuming this is like the distance of it, how far the light is emitted from the center. So in order to reach Neptune, we need 5 million.
5 million.
Because 5 million, hold on, 5, 1, 2, 3, 1, 2, 3. There, that's the range that we need. Now, where are the other planets? Did they end up getting inside this? Let's move them outside of it. Real-time indirect bound shouting is not supported for spot and point lights. Okay, well, I'm happy.
I think what it's trying to do is increase the point light, its scale, until it takes up 5 million.
I don't know what indirect multiplier is. All right, let's find Earth. Where's Earth? Okay, let's take Earth, get it outside. There's Earth there. Let's take Jupiter, get it outside.
Yep, that's changing it. So Mercury, I think.
So that's the intensity of it. Yep. Intensity is it's super intense here. Let's go back to the point light. Drop that intensity down. Change it back to 1. Looks a little better at 1. Right there, see it?
It does.
All right, cool. So that's Earth. That's Jupiter. Do you want to throw a wrapper around Earth? Get the texture on Earth.
Earth.
So we still haven't figured out how to, Options Max is here. Cool beard. Thanks so much for the beard compliments. Welcome. There's Earth. Maybe not darkness, because it's, it's interesting. We can't quite get, I'm not sure how exactly we would fake it. What are you doing with transparent?
I was making this one more transparent and then adding, I can't add 2 at once.
Yes, so you need to create a second sphere that's going to be the clouds around it. If you want to do that.
Duplicate.
We've also got another light, that directional light. I want to kill that. The one at the top. Kill it. Better.
Now we should make the intensity on this, I think, bigger by a
Also, let's get rid of the skybox, whatever the heck's in the back outside. I think that's part of main camera.
skybox?
Yeah, the thing that's showing the sky. I think it's in main camera. Is there skybox? Yeah, look at that. Clear flags right up there. So it says skybox. Solid color. Something happened to in our rendering in a really weird way. I think we maybe don't want that. The scene looks okay, but that's not what we want. Can you undo those options since they're not what we want?
Why is it?
Can you
Wait.
undo those options, Campbell, before you
Yes,
make any other changes? Can you undo them? Just hit Control Z, Control Z. One more time, I think. Why did we lose? There it is. All right. So we're going to stay there for a second.
I think that if there's no light hitting this one, then it just glosses over as this color. Which is weird, because I feel like the light being emitted from it would change that a bit.
I'm not understanding what you're saying. Can you say that again?
I feel like when I think the problem is the light is shining onto the sun and it's giving it light.
Right. Oh, okay.
Whereas-
So when the last undo step that restored that is when we restored directional light. Is that what you're saying?
Yes, and I think what the problem is that every other planet is fine because they have the sun as light, but then the sun is the only one that.
Yeah, we got to figure out. We haven't really figured out how to stop the shadow on the sun, and how to make it be an emitter. We haven't figured that out yet. Let me just double check that to confirm. I'm going to select directional light. I'm going to hit delete. Yep. Okie doke. So there's something problematic with our directional light on here.
I think it's a problem with our sun.
Let me try one more thing. Let's see.
Light.
I have an ambient light. I don't have an ambient light. I have an area light. I wonder if that's the same as the ambient light.
Doesn't seem like it's doing anything.
Yeah, it doesn't. You're right. So, okay, delete the area light. We may have to look this up. Let me maybe look this up. Unity. What is it? Texture that only emits light, no shadows. Maybe something like that. So kind of hits I can get to help us out there.
That's pretty nice for Earth, right? If I can say so myself. Or should I make it a bit?
Well, I'm sorry, what were you asking? You doing the clouds?
Yeah.
Over it? And did you make the radius larger?
No, I didn't. I
Yeah,
should
definitely
probably-
make it larger for that. Wait, I think it's super small.
Why is it this small? I thought I.
Oh, wait. No, wait. This might be okay. You might be okay. Make it 1.1, for example, and see what happens. I think you'll see it pop out.
Oh, because it's parented, right?
Yeah. Try 1.1. Did you do it?
Yeah.
We saw a change. Yeah,
We did.
there was a little bit of change. Okay.
Yeah.
So there you go. Then it's funny though. It's like it's not quite what we want. You know, I kind of want the black parts to be transparent completely. Is what I think I want. Your Y should be 1.1.
I know. I'm working on it. Oh, that's a bit too big.
Yeah. So try 1.01. And then to quickly check it, right? Create it, copy it, tab, paste, right?
Control A. Tab, Control B.
Yeah, I'm thinking it looks better with the. And then let's turn it off. Can we make it invisible? I think there's a way to click over on the hierarchy on the far left.
I can do that.
Okay, there. I don't know. Yeah, it's like it's kind of got a muddied look. My contrast is kind of low.
It
Granted,
does.
there's not much light hitting it. Can we turn around so that we're seeing the light from the sun on it? Yeah, turn it off and turn it on. See what we like better.
Huh.
I think the light is also too orange. It's kind of turning everything it's kind of getting that muddy kind of color there. Can we?
Make it light.
Yeah, let's do that. The color of it. Move it closer to. Yeah, that's a little better.
That's much better.
Make it between the two. What I'm thinking here. Can I move the mouse over?
Wait 1 sec.
Just drag it a little bit. You kind of practice there. Move it to the left. Drag it to the left.
Oops.
And see what you like on the earth. Like there is looking and feeling pretty good to me. Right about there.
Hello.
Hide your wallet.
Did you just say hide your wallet? Is that what you just said? Did you just say that? You're in trouble. That's you.
What do you need?
Oh, what are you doing?
We're modeling the universe is what we're trying to do.
We've been doing this. This is part of Campbell's thing today.
Can you show Mom Earth next to the sun?
Oh, yeah. So, wait, where is it? Did we lose Earth?
Uh-oh.
Wait, no, it's right there.
Just
So,
on the other side planet.
wait, that's not Earth, that's Jupiter. So,
The
this
big one
is
is
Jupiter, this is Earth.
That's
Wait,
Earth
let me
right there.
move it.
Boys go to Jupiter. Yeah.
Can you zoom in so you can kind of see both? Well, oh, you moved. Hold on. I think you moved the inside of Earth, but not the outside. Or you moved the outer planet that was parented by the
I
inside.
did?
Yeah. See what's going on? See one's down below?
Oh, yeah. Wait a
You
minute.
can undo that. Just undo it. Just hit undo.
Neat.
Or you
Campbell,
do
are
that.
you incorporating this into your presentation today?
Sure. Oopsies, I did it again. I have to
The
make this
reason
one.
why is because the one that's parented by it is bigger. So if you click on it, you'll click on the bigger one and it'll select it. We might want to change how we're doing Earth in there. We might want to take out the clouds.
So this is it, Mom. This is Earth, and this is the Sun. And then this is Jupiter.
Oh, wait. So I don't see Earth. Where's Earth?
It's right there. It's like a little pixel.
Wow.
Super small.
Well, that's some perspective. I was feeling pretty,
Good about yourself till now?
Yeah, I was. I
Oh,
was
well.
feeling like the dominant
Go.
species on the dominant planet in
Yeah.
the dominant solar system.
You should go study up or do something. You know?
I should, but
Like-
probably not.
No?
That
Okay.
doesn't feel like something
Alright.
I'm going to do.
Do you want to put the Earth and Jupiter the right distance away from the Sun?
It's a good idea.
I think what I want to do,
Is first just get the
I want to
How
play.
many Earths
I
go
want-
into the sun?
I want to
well
explore
100
with.
for the diameter, but it's way more for it.
What did you say, Campbell?
It's about 100 Earths for the diameter of the Sun.
For the
100
diameter. So you
Earth
get 100,
diameters.
string them across the middle, and you'll get the sun. It looks like you probably need like about, I want to say like a million Earths if you want to fill up the sun.
It's a lot.
I don't know for sure, but we can figure that out. So I kind of want to let's.
I'm
figure.
leaving you. Bye.
You're leaving
Bye.
me? Okay. All right. I kind of want to play with the idea of feeding data to a method that creates these planets. I wanted to try something with the sun. Before we go into code, I want to just come into the sun for a second, and I wanted to play with. Tribute global illumination. We tried that. It did nothing, right?
I tried that, but I didn't completely experiment with it. Oh, that's what we want.
That was lucky. Holy cow! I loved it. And
Now
we
let's try
also-
turning the direction of the
wanna
light
make,
off.
I want to make sure we've turned off this thing, rendering mode. Yeah, opaque, color mode. I'm fine with that. What did you say you wanted to do, Campbell?
Turn off the directional light and see if it still works.
On the outside.
No, I think that didn't do anything. We have to actually delete.
It's looking good.
Oops. For some reason, when I get too close manually, it just disappears.
Which part?
the sun, everything.
Oh, because you're probably inside it.
Oh, no. Oh, wait, before it was, I wouldn't get inside it. I would just get like a little bit close and then I wouldn't be able to see it anymore.
That's looking pretty good. Okay, next, I want to figure out how to turn off the skybox in Unity.
Okay.
So let's just, can we review what I just did? Because it was kind of like I stumbled on it.
No, I feel like we learned how to do it before, how to remove the skybox.
Right.
But we never chose to do it.
It was a material I think we threw at the main camera, if I'm recalling correctly. Go back to main camera. Click on the main camera.
Look, we
That's the word skybox at the top is really. Ooh. Okay. Wait. What did we give it a material?
I don't think we can.
I think we
Okay.
can. We remember we threw the video at our first game we tried.
That was a component.
Hold on. Wait. I've got a star. See the stars right there? Look at right next to the sun. You're trying to drag the sun on something. I've got stars. Let's drag the stars onto it. Is what I want to do. It's not taking it there. The background. No, wait.
Oopsies, did I just do something wrong?
Yeah, undo it. Let's undo for a second. Hold on. Background. So no way to specify a file.
Wait.
there.
Oh, wait, no, there is. Look, ready? Solid color. Ah, no. I was thinking that maybe in here we could do... Doesn't work.
Okay, interesting.
We could only make it a solid color, or wait, can I experiment with the depth only?
We can throw like a plane out there or something like that, but I'm not really liking that either.
So, I bet you we can upload an image to a canvas. Wait, raw image. Image or raw image?
I'm sorry, my eyes are on my machine right now.
Stars. So canvas. Wait, stars just, it looks black to me. Oh wait, I have the wrong one.
Well, you threw a canvas out there.
I did.
Canvas is what is, I think, showing up for user interface work. So that's not behind us. That's not in the background. That's in the foreground.
What? Why isn't it's not taking this one. It's a JPEG. It totally should work.
Wait, but I don't think you're seeing what you're understanding what I'm saying. See, notice in the game how it's completely black? The canvas is between the camera and the objects. We need something in the background. If we open up our game, I'm trying to remember how we did this. We did something in the game with this. Remember our first game, Campbell? I can open it up on my machine. Do you remember our first game, Campbell? Yeah. Our first game had the video playing on the background. Do you remember that?
Yes, I do. That's what I was trying to do, but with this, and I think I'm super close.
But I don't think it was with a canvas. If it's a canvas, it's a canvas. So we have to say we want to put it at the back of the camera plane. And I don't know if there's a way to specify that in the canvas or not.
No, this isn't what I want either. Why isn't it showing up as a material?
So I'm starting up on my machine the first game that we created. See if I can find clues in there.
It's not registering this as a material, it's registering it as...
I think you have to create a new material and then put it inside it. The material isn't like an object that has properties, but these are just files.
Create. That doesn't work either. Oh wait. Oh. Hey.
I'm sure why it's so hard. This was I felt like we didn't take this long for us to figure this out before. And I remember seeing like an option in the camera. It felt like
Canvas doesn't move either.
Let me drag the mouse while I'm waiting for Unity to load up. Let me just come over here and explore. Is that okay?
No, I'm working on something.
I didn't hear you. I need you to speak a little louder.
I'm working on something right now.
Okay. Tell me what you're working on.
I'm trying to get the stars in the background.
And what are you trying to do? Oh, you still work on canvas. See how it's black though? Oh. Are you maybe going to get it to work?
No, this is the solid color. But where's the
okay. Yeah, when it's black, I think you're looking at that other image that's showing up because it's a canvas. Canvases are used for user interfaces. You know, they're used for drawing things, you know, on the display. I don't think you're going to have success with the canvas.
Nope, working on something.
I'm not finding any clues in our game. Let me switch over to my machine and you take a look at what I'm seeing here. Is that okay?
Sure.
Take a look. So, if I play the game, notice we don't see the video. We do see the video now, right?
Yeah?
See it?
Yes, I remember doing that.
Okay, now watch. If I go into camera, camera says skybox. Background is this. Culling mask is everything. Switch on your camera. I want to see what yours looks like next to mine. Select your camera, Campbell. Okay, so you've got changed it now to solid color, which is like, okay. Back over here on my machine. Culling mask is everything. You have the same value. Perspective, vertical, field of view, same values. Clipping planes are slightly different, actually pretty close though. Viewport rect is the same. Your depth is the same. That's the same. Target texture is the same, which is none. Occlusion culling, use graphic settings. Use graphic settings. Allow dynamic resolution and display 1. All of these are the exact same with your camera. So it's not the camera.
It's adding.
What'd you say?
It's adding a canvas.
There's no canvas here though. Look at what I've got. We did.
Yeah, because
wait,
it's a
there is a
video.
canvas. No, but the canvas only has these 3 things in it.
Yes, but because it's a video, it's different.
But where is it? Is I guess what I'm saying.
The video. There's a video player. I think it's called Wormhole Maker.
It's called what?
That Wormhole Maker. It's right below player.
Wormhole Maker.
It's a video player.
You sure?
Yeah,
oh, it's
look.
got a video player right there. That's the purple pink wormhole. Ah, there it is. Render mode. Camera far plane. See it?
Mhm.
So we need to drop something on that's like its own game object, and hopefully it's got a render mode and where we can put it. Maybe? Can we do it like just with an image? Is there a way to drop an image in?
Maybe.
It's got to put a canvas in. Is that right? When you added an image, it went to create a canvas?
Yeah.
Well, we can look at its properties, see if it's got a render far plane.
You could also try raw image.
Let's just go with image. All right, is there a render far plane? There's not. Interesting. It wouldn't let you drag that over.
No.
Yeah, and it's blocking because it's canvas. Yeah.
And
That's
then
not
we
gonna work.
can't move the camera.
So it looks like the solution we could do with video, but we need to create a video of the stars. Did you hear that, what I said?
Yeah, I did.
What do you think about that?
I guess, sure. Try it.
But, well, I don't have a video of the stars yet.
No, but no, not a URL.
So I think we'll have to make a video of stars. That's what I think we're going to have to do to get that. It seems like there should be a better way to do that. The far plane. Maybe I can do this. Image on the far plane. Let me do one more search. Unity, image, far plane. Got any options there? Texture on far clipping plane of the camera. Oh, well, I got to here. How can I say the texture on the far plane? Is it possible? But no replies. So there's my question. That's what I wanted. And they won't let me vote it anonymously. Too bad. It's like such a simple thing. I'm trying to figure out what I need to search for.
I feel like it should be a similar thing to adding a video player, but with, like, there should be an option to change it from, like, video clip to just an image.
Yeah, let me see. I'm just on your. Let me just check. Take a look and see if there's anything that triggers my, you know.
Wait, no, it isn't. Wait, can I try something?
Mm-hmm.
I think.
Look at draw mode.
Draw mode. Oh.
No. Okay, no. That's
But
definitely not that.
I remember. In here, let me just.
What is I'm sorry. Go ahead.
Dang. Wait. No, it's not that. Well, not sex. Huh.
I'll tell you what I think we might want to do as a really kind of a. No, maybe not. I was going to say, let's give this a little more thought. Try to see what we can come up. If we restricted the camera view to one angle, then we could just put a plane in the background and drag it, the starfield onto the plane. In fact, I think, why don't we do that now, since, you know, in the interest of making the show a little more interesting than just watching us kind of do searches and stuff like that.
Plane, you say?
Let's create a 3D,
object, right?
no, 3D, like a cube. Or plane. I just saw a plane in there. All right.
Now I gotta make it a lot bigger.
Make it a lot bigger. Make it like 1,000,000 by 1,000,000 by 1,000,000. Or the X and Y only need to be 1,000,000. And we can assume that we'll be looking right at the Z, down the Z axis on it.
No, we're looking right down on the y-axis. So I think the Z. Wait, that's not what I wanted. 3.
Make sure I can hear you, because I'm not. It's because of the
sorry.
distance between us. It's hard for me to hear what you're saying sometimes.
Okay. Right. Now we should probably rotate this accordingly. Oops.
The plane is just moved up past it. There you go. There you go. That can kind of work. It's, you know, a cheap solution for now.
And then.
So tell me about our orientation. The camera is, we're not looking down the Z-axis, we're looking down the X-axis. I see.
No, the y-axis.
No, we're looking down, we're kind of looking down both the X and the Y. See it? But I'm trying to imagine, okay, if we're going to line up the planets programmatically, how are we going to do it? Which axis are we going to look down? For me, it's kind of like, I kind of like keeping X and Y when they're traditional places when we learn things. In other words, yeah, I want to look down the Z-axis. That's what I want to do.
Why is it so rotated?
I don't know, because it got rotated maybe.
Oh, I rotated it. Haha, I forgot that.
All right. So let's do this, and let's change the position of the planets too. So we'll keep X and Y where they normally are. And then we'll be looking straight down the Z-axis. And then I think that'll make it a little bit easier.
And then make this 0? No?
Make it 1 at least. No, I don't. Maybe you're not understanding what I'm saying. I want to look down the Z-axis is what I want to do. So, can I grab the mouse a second on this and just move the camera?
Yeah.
Is that okay? All right. So what I want to do is I want to look down like this at it. That's what I want to do. So I want the camera to be here, the planets left and right of this, or maybe just left, whatever. That means I want the plane back behind all that. So I want to kind of do this, and then move it back, way back there. Maybe not that far. Really? All right, hold on. Let's center this on the X and Y, center it behind the sun. Just gonna get this closer. All right, now let's make it way bigger.
Then we have to move the camera.
Okay, and we have to do what?
Move the camera.
And cast shadows is off. Receive shadows is off. I also wanted to receive, I don't want to receive light. I wanted to do the same trick that we did before with the sun. I wanted to only emit. is what I wanted to do. And how did I do that, Camel?
We went down to, first we had contribute to global
Ah,
illumination.
okay.
And then in here, we went here, particles.
And I think I did surface.
No, it was standard surface.
Nope, it was unit. That's what apparently
Was
I
it?
did. Okay.
Wait, it feels like it just took up everything.
Okay, so now our question
it's
is,
just
so, okay, I think we're good. I think we got to go to our camera and increase the clipping distance, the far plane clipping distance.
No, we have to move the camera first.
The camera's looking good. Look
No,
at
the camera's not in the right place.
well, but it's close to the sun. Well, you think it's aiming to the side.
Yeah, but
Okay.
it is.
Okay, cool. So let's fix that. I'm not really seeing the stars from that. It looks like it's kind of weird and like kind of zoomed in.
Oh, no, the sun is way too far. I forgot about that. Yeah, it is because you made it. It's really big.
No, maybe we can shrink it down a bit. Get the stars better. Tell me when you got the camera in the right place, and then we'll fix the dimensions of the plane, the back plane.
No, not working again.
I didn't hear you. Can you speak up?
Main camera, moving it to the scene view isn't working.
I'm sorry. Can you say that louder, please?
Main camera, Control Shift F isn't working. Align with view. Again.
Let's go take a look at that. So you're here and you hit Control Shift F and it's supposed to change it. Is that right?
Yep.
What's the menu option that it
Game
goes?
object and then align with view.
Like that. So the camera we want to align with this view. And we believe
Yes.
that's not the case. It's not changing at all, which means if we came in and moved the camera, and then I came back in and said main camera align with view, we should see something change or update there. I didn't notice any changes
No
there.
changes or updates.
That's kind of interesting. Just jumped right into that. That time it worked. You see that, Camel?
Yeah, I saw it.
I see, and it seemed to be inspired by. It seemed to be triggered by changing these to 000. Kind of a little bit weird. All right, are we looking in the right place now?
Yeah.
Can we go to plane and can you drop it the size of it down, please? Scale it down.
Plane.
Take off a 0. That looks better.
Aha.
Take off another 0.
Maybe, yeah, I was about to say. Uh-oh. Wait, that might not have been the best. Okay. Before revealing.
It's a little bit better,
Wait, can I?
but it doesn't seem big enough. We should be able to.
Yeah, it is.
Okay.
Yeah, we
that looks
just
good.
had to move it a bit.
Pudding says we need texture that changes over time and makes the sun look like it's burning too. That'd be a cool feature to display later on. Yeah, I need to create that that texture, but that's not. I'm not feeling like that's my thing right now. But maybe if that was available somewhere, I would totally grab that. It would be super cool. All right.
Oh no, I don't think we can see Earth at all. Well, we kind of can, but it just looks like a star.
The Earth does.
Yes.
Yeah, it's going to be one of the tricky things about showing this. That's be a little tricky. Also, if you had a light source from the sun, we did do that. We've added a light source from the sun. All planets will have shadow on the side that's not facing it. Yay for automatic logics. Yeah. So we do have that right now. We have a light source coming from the sun. So it doesn't matter where you put that, it's going to look like it's there. So my thoughts are,
Yeah.
I kind of want to build the planets and stack them.
Stack them as in.
Yeah, kind of put them next to each other so we can kind of see them.
Okay.
Well, I don't know. We got a couple options that we can do. You know, that's mine. That's my idea. I was imagining we could have the word of the name of the planet nearby it and its statistics. I was thinking we could actually position the planets at their distances and build the rest of the planets programmatically. I don't know.
Okay, then let's do that. Let's do moving them to. Let's just stack them for right now.
Did you see the error message down at the bottom?
Yeah, I saw that. I don't think it's really anything.
I wonder if that's related to all the times we tried hitting Control-Shift-F when we had bad values. Remember when I switched it to 0, 0, 0?
Yeah.
We had better values. All right, hold on. Mouse is on your screen for a little bit here.
Oh, wait. If we do maximize on play, the plane is not big enough.
Say that one more time if I do maximize.
If we maximize
Oh, the plane is not big enough. Yeah. I think there may be a way to tile.
Oh, there probably is.
You want to look for it?
Yeah.
See if you can figure out how to tile
Material?
the material that we put on it.
Actually, that might not be it. Tiling. Let's just make this
I think there's
channel.
an option to tile somewhere. I don't know if it's necessarily, it's here, tiling.
One. Oh wait, no, this just keeps it the same size, but it puts multiple on there.
It does what?
It puts multiple of the same image in.
Good, so do that. So let's make those
No,
4
but
and 4.
it doesn't add more.
But
just-
we'll stretch it and we'll change the tiling. So let's make it 4 and 4. And then, so we've made all the stars smaller. Then now let's make the scale of the plane 4 times bigger.
Okie dokie.
Yeah, I think you can type in times 4.
You can. Times.
And since that's so simple, we could also just change it to 4 at the very front of it. You just edit the front one and turn it to a 4. Good. See that? Okay, so that works. So tiling, we increase tiling and increase the scale. So tiling just means how many of these are going to appear.
Oh, wait, Earth might be a bit bigger now. Nope, still pretty small.
Is it on the same? Is it on the same Z position as 0? All of the planets should have Z as 0.
Okay. Jupiter.
And let's make Y 0 as well.
Yeah.
So they're all lined up on the X-axis. They're just positioned somewhere on the X-axis.
Earth.
That's good. Oh no, wait. I'm sorry. I was looking at rotation. 0 and then 0. Good.
And then 0.
And Sun too, but I think Sun is at 0, 0, 0.
It
Is what we
is.
did.
Yeah, Earth is so incredibly small, I think.
All right.
That is it? Wait, let me just maximize. I think that's it. That's Earth. Yeah, it totally looks like a star. That's a problem.
Wait, I can't hear you. I need you to speak up. Remember to speak up so I can hear you.
Earth totally looks like just a star.
Yeah, it does from a far enough distance. Are you? What do you have now selected? That's Earth right there. Okay, can I actually come over and grab the? I want to just come over here. This is not the right distance, but I just wanted to say if the Earth was only that distance away from the sun, that's what it would look like.
Mm-hmm.
And then if we got to the Earth, let's just jump into the Earth there.
You can double tap Earth in the hierarchy.
And then let's spin around. Yeah. So we know, based on how big the sun looks when we look at it, we know that the sun does not look that big. I think if the sun looked that big, it'd be over for the Earth. The Earth would look like Mercury.
Yeah.
Right? Okay. So here's what I think I want to do. I think I want to turn these off, and I want to start programmatically creating these a little bit. Maybe not the sun, because the sun is this kind of special case thing. We had to set all those settings on the sun to make it emit,
Yeah.
right? And it's got
And
a
that
light
would be a
inside
lot
of
of
it.
code to do. So
What'd you say?
and that would be a lot of
Yeah.
code.
It would be a lot of code. But I think for the others, we need to figure out the sphere. We need to maybe put the distance away from the sun. And I think that's what we need to do. All right, why don't you create a game logic or a simulation logic object and a script to go with it.
Okie dokie.
I'm going to do a search for controlling the Unity camera in the game. So I want to be able to move the camera to the different
So I think we're gonna need to use fixed update totally, because it's all physics.
A little louder, buddy. Did you say that again?
I think we're gonna need to use a lot of fixed update because it's a lot of physics and the physics.
Because it's a lot of what?
Physics, because fixed update handles the physics portion.
Yeah, we might be going in that space. We've got the game logic here. I think that the I'm imagining the start of game logic looking something like this. Create planets. Like that. I think it's looking like that. And then
put planets in right position.
and then in here, I think we want to do something like this. Create planet. And I think the call looks like this. We're going to pass in the name of the planet, Mercury. We're going to pass in more data on it. Hold on, let me get some data for you here. Switching back to my machine so we can see that data. This is where we are, solar system. I'm looking for that table we were at. Planetary statistics table. Here we go. Let me copy this. Copy that. Come over here and paste it in your machine, Campbell. Comment out that for a second. I'm just going to paste in this. And then I think it's something like this. It's like create planet Mercury, comma, and then this is its distance from sun. So its average distance from sun is here. You don't need miles, comma, and then its radius or its diameter is there. Its time to spin is there. That's its spin time. And then its orbit time is there in terms of
Earth days.
Earth days. There's its gravity right there. And its average temperature is minus 183 degrees.
I don't think we need to know that for creating it.
Yeah, okay, but we could just put it, if we store it, if we knew it, we would, that's its average low temperature and its average high temperature. We could then show it, right? It's kind of, I'm thinking about the future is kind of what I'm thinking about here. Then its contents of its atmosphere are that, sodium and helium. And number of moons is like the last piece maybe. Or we'll say 0 for number of moons. And so that's what I'm imagining one of those would look like. Let me comment out the rest of this for a second. Let's declare create planet. And so we've got all of those name all of these parameters. So this one's going to be its name. This one's going to be its average
Its name is a string, not a
distance to
Oh,
sun.
wait, you already made it. Oh,
Wait, what did you say?
nothing. I thought that the name was still an int.
No, I got you.
Yeah.
I got you. In fact, I'm actually thinking about changing create planet to new planet instead. Is what I want to do. I want to create a new planet. I want an object class called planet. So I'm going to come in here and I'm going to say, let's declare a class. And so now I've got a class called planet.
Uh-huh.
And we're going to pass in the constructor to it. We're going to pass in those parameters, and we need to actually add the additional parameters here. Let's do that. All right, so let's go into planet a second. And so we've got these, it's given us a constructor and it's named all these fields like v1, v2, etc. like that. So, and we want to declare property for name, and we want to declare a property for average distance to sun.
Uh-huh.
And okay, let's get rid of these two here, so I don't need those anymore. And then we need to just take care of v1, v2, all of those all the way around. The next piece is diameter. That, I think it's going to be easier if I delete all of these and delete all of these, and we're going to come back in and declare them one at a time after we get the names right up here. Which looks like I got rid of name. Okay. So the third parameter after diameter was time to spin in a day. So a day spin time. Next one was orbit time. So that's a year. Maybe year orbit time. So we'll do that whole thing so it's very clear what it is. After that, we have gravity. After gravity, we have average temperature, average low temperature, and then we're going to have an average high temperature. Contents of the atmosphere. So atmospheric contents. And the last parameter is number of moons.
Of known moons. Okay.
What'd you say?
Known moons.
Known moon. Wait, are you saying known moons?
Yes.
Okay. Cool. I just realized that my machine was, I was showing you my machine the whole time. That's what I meant to be showing you the whole time. I want to change all of these to doubles. So I'm going to copy that and I'm going to hit Control B here, which is paste replace for everything that is a number that could be a decimal point or something like that. The number of moons, I will keep it as an int.
Yeah,
so
because
we're
you
going to
can't
change. What'd you say, Campbell?
Because you can't have a fraction of a moon.
Right, exactly. Next, I'm going to come in here and I'm going to use the code rich feature. So I hit this, I'm going to choose declare property with initializer. And so now look what it does. It adds the property and initializes it to the value that's passed in.
I bet you could shift enter on all of these and it might get it right.
No, it does not, unfortunately. I know where you're thinking. It would, shift enter would work to create more parameters, but because it kind of duplicates those pieces. But this is something where I'm actually declaring a property and initializing it. So this is what's happening with each one of these. I'm coming in here saying declare property with initializer. There it is like that.
And then
And coming in there. And the last one.
Number, yeah.
Okay, so there's our planet. Now if we get back over into game logic over here, we've got a new one. We can, I guess I'll declare a new local right here, call it Mercury, like that. And then we want to go down and get down to Venus, is what I think we want to do. I think I want to do something like this. Venus is equal to new planet, like that. Then we're going to throw this data at it. So now we've got that, kilometers, we don't care about miles. Got this right here for its diameter. Its daytime spin is 243 Earth days, and it's wow, its day spin time is really long. That means is it moving fast or slow?
Super slowly.
Yeah, Venus it's not moving practically.
Wait, it takes longer for a day to go on than a year.
Yeah, in a year. Is that blowing anybody's mind yet?
I think. What?
Earth's gravity is 0.9. It's 0.9
Wait,
of
Venus
Earth's. I'm sorry. No, wait. It's. Oh, yeah. This is gravity in terms of Earth. That's interesting. So this is not its gravity. Let's come back over here. This is gravity relative to Earth. Is what this is.
I feel like we might want to put in just gravity, like actually find out what its gravity is.
I would totally agree with you, but we can figure it out based on what we know. Hold on a second. This UI is kind of getting in my way. I can't get rid of. Can I get rid of that? And keep the rename going. Can't from here. Okay, so let's go down here and rename this gravity relative to Earth. Or we could do this.
Wait, what do they mean relative to Earth?
Times Earth's gravity, which is what?
Earth's gravity is, I think it's 9.81.
9.8 meters per second is what I got.
Sorry.
So what I'm going to do is I'm going to take their gravity relative to Earth and multiply 9 by 9.8. And that's how we'll get the actual gravity. Does that make sense?
Yes.
Okay. So the gravity relative to Earth is what we're going to pass in, but we're going to fix it to normal gravity, and so we'll get something else out. Okay, so now we're at, what are we at here? Average low temperature is 480 degrees Celsius. Average high temperature, wait, I don't have it.
Oh?
Oh, it's the same for both. So it's 480, 480. Its average high and low are the same.
Wow.
Okay.
Very
Next,
constant.
we've got carbon dioxide, 96%, and nitrogen, 3.5%, and zero moons.
I think we should just change it to carbon dioxide, nitrogen, because that's what we did with the other one.
Okay, we could do that. We could totally do that if you want. But you know what? I kind of like it instead of going with less information. I kind of like, let's go with the information we got.
Okay. And then with sodium and helium, we can always change it.
Yeah, we can always change it. We can also get rid of stuff if we want to. All right, next we're going to come down here. We're going to do Earth. I know about this planet. Let's see what we're going to do here. I'm going to take that and I'm going to just paste it in here. And let's start modifying that data. Uh-oh. So 23 hours and 56 minutes.
For what?
This is for 1 day. What is a day equal to?
Oh God, that's gonna make it a lot harder to.
Let's do this. We're gonna say a day is an Earth day. We're gonna go back into planet again, and we're going to change. We're gonna rename this one right here to spin time in Earth days. like that. Then we're going to say the spin time, the day's spin time is going to be equal to spin time in Earth days times an Earth day is equal to, we said,
hours.
yeah, hold on, we've got,
23 hours and 56.
let me think about this a second. There's something called time span, and we can say from days, hours, or minutes. And I want to say from minutes, and I want to pass in 23 hours times 60 plus 56. So that's 23 hours and 56 minutes.
So it's 23 times 60 is, it's the equivalent to 23 minutes times 60. So it equals 23 hours. And then plus 56 minutes.
Yeah, 23 hours and 56 minutes. That's that. Then we want to say, let's turn that into, we're going to come back from that, and we're going to come back and say total days. And that's going to give us a fraction of that's something of what that is in terms of the total days. So it'll come back as a 0.96 or something like that.
Yes.
And so when we set the day spin time for the Earth, it'll be 1 times 0.96, or we'll get the day spin time, which is, 0.96 of what we traditionally call a day, which is 24 hours.
Yes.
That's what I believe was going to happen with that. So the day spin time is there. The other time we think we could do is we could just convert it to hours instead. We could convert this to total hours if you want to convert it to hours. But I kind of like the days because that's kind of a good unit of measurement for spinning.
Yes.
That's what I
I'm
think.
still so mind blown by the fact that it takes Venus, 1 day on Venus is longer than a year on Venus.
Yeah, right up there. Yeah, time to spin on the axis is 243 days. You go around the sun in shorter time than you go from one side to the other. That means you could probably, you could travel around the planet. I don't know if you could walk around it in that much time, but in a year. I need to do a little bit of math to figure that out. But you could certainly travel around the planet and always stay, either on the dark side or on the bright side if you wanted to. Okay, let's go back to where we were. So we were in Earth. About to change this to Earth, it looks like. And then now...
That means that one night on Venus, it's what? Like, 121 days for one night.
Yes, that is correct. All right, so we got average temperature on Earth is about 14 degrees Celsius. Cool. And then the contents of the atmosphere. And number of known moons on the planet, 1. Okay, so we're going to keep the rest commented out for now because I don't want to just go through that for right now. But
yeah.
That's what we've got here. Looks like there's a problem here with this planet. What's the problem? Number of moons. Looks like I didn't do the low temp. Like that. So average low and average high are the same on Earth. Okay?
Yes.
So now we created these planets. These are all local right here. And I'm kind of thinking I want to make them, I'm going to use a refactoring called widen scope, promote to field. I want to turn them into fields is what I want to do. Do I want to the creation step separately? I think we're okay here. If I do this, I just widen the scope. We can actually do this here. And when the class is, created, all of these will already exist. So maybe we don't need the call to create planets anymore if we're going to do that. But maybe we need something called position planets. Like that instead. So we've got our planets. Now we want to position them. Oh wait, hold on. I'm going to go back and call it create planets because these, while we're creating these individual planets, we haven't modeled them yet. So what we want to do is we want to say model planet and I want to pass in like Earth. Okay? And then I want to model planet and pass in Venus.
And that puts it in the right place, right?
Yeah, that's what we're and then I'm going to do the same
And
with
the same
Mercury. All right. So now we got to figure that out. What does the model planet look like?
I think it would have us use the diameter and put that in it for its scale, and use its distance from the sun and put that in its transform. Because if the sun is always
Right.
0, 0, 0, then the distance from the sun is always what the transform will be.
The distance from the sun is always what?
If the distance, if the sun is always at 0, 0, 0, then the distance from the sun will be what we want our Z transform to be every time.
Right. Yeah, I think that's absolutely right. Do you want to? Normally, when we create an object, we call instantiate, and we give it a prototype.
Normally,
But we don't have a prototype on the here, and we kind of just create a sphere. I'm wondering if there's a quick way in Unity to create a sphere using C#. I'm doing a search for that right now. Create a primitive.
Wait, what if we just use one sphere and then instantiate that every time and then add everything to it? When we instantiate.
No, we could do that, but look what I just found.
Ooh.
That right there. So let's do this. I'm going to grab this code. I'm going to throw it over here with you, model planet. So we're going to say game object. I'm going to call it planet, like this. And now what I want you to do, what's going on? Why is it underlining this? Local, oh, we've got planet here. I'm sorry. We're going to call this planet model or planet object. And I want you to see if you can figure out what to do now.
Okey-dokey.
You said you wanted to position it. You said we want to scale
to
it.
position it and then scale it.
Yeah.
Yes. So, should I start back? Wait. Huh. So,
Meanwhile,
wait.
I'm going to search for something else while you think about that. Unity, add texture
Be a code.
to game object in C#. I want to see how we can grab an existing texture.
Z. Oh, dot.
Okay, I got an answer to that. And I'm ready to try something when you've got a moment here. All right, here's planet object transform.position.z.
Oh, right, that's not a variable in here. So,
The planet. So you've referenced the class planet.
Yep.
You want to reference the parameter planet, which is on line 18 and starts with a different case. See line 18?
I don't think that's the one I want to reference. Because in the class planet, we have the distance from sun.
Right, but go back to line 18 in the other piece. Line 18, see it's got the green planet with the uppercase P, and after it, it's got the lowercase p. That lowercase p one is the parameter. The piece to the left is the type of it. So the parameter is that lowercase one. That's the instance. It's like the cookie. And with the cookie now, you can go access the properties inside of it. And remember, these numbers are all going to be 1,000 times bigger. Average distance to sun
Right.
is going to be in kilometers. Does that make sense?
Yeah.
What if we did this? I have an idea here. See if you would find this easier to use or harder to use. We come into average distance to sun, I'm gonna rename this, and I'm gonna just put a km at the end, so we know it's kilometers. Is that okay? That kind of looks weird, sunk km, but it's in kilometers.
We end up dividing it by 1,000.
Then I'm gonna do this. I'm gonna create a read-only double property called average distance to sun. And what are we going to call these? Units? Average distance to sun. What are we calling the unity units? Kimball? UU for unity units?
Sure.
And then I'm going to say it's equal to, in my return, I'm going to say return that divided by 1,000. Like that. So now then over here we just use the UU instead for unity units.
Okay.
What do you think about that? Is that easier? Does that feel easier to use?
Yes, it does.
Now don't forget you cannot assign to the Z. Do you remember that?
Yeah, you can.
What'd you say?
Yeah, you can.
I'm still not hearing you. Are you saying you can't?
Yes. Yeah, you can. We've done it before.
Not really. Not a direct assignment to Z. Z is a read-only property. And look at your error. It says cannot modify the return value because it's not a variable. So I can't assign that. What I can do you remember how we solved this?
I have a way to solve it.
Okay, what's your way?
I know the other way to solve it, but that was a lot more code.
Do you want to talk about it before you do it, or?
I'm gonna set this to a variable.
Nope, that won't work either. First of all, your planet object, you've moved it out of the method. It's kind of a clever idea, but it won't work either. And part of the reason why we can't do it is it's actually trying to protect us. There's something called mutable, meaning I can make changes to it. And there's something called immutable, meaning I cannot make changes to it. And that Z is immutable. You cannot make changes to it on purpose. It's there to protect you. And I think it's an uppercase P there. If you hit Control Space, it'll fill it. And you're going to have the same problem here. The problem is that you're dealing with a vector 3. And vector 3, its X, Y, and Z are immutable. They cannot be changed. Pudding says immutable. I need acknowledgement from you so you understand they cannot be changed. Before I get to go on to the next thing, I just want to make sure you're with me. You're with me?
Yes.
All right. So, but here's what we can do. And you should recognize this because we've done this before.
I do. But it's a lot.
New vector 3. And I'm going to say my X is 0, my Y is 0. I'm sorry, my Y is 0, and my Z is that. And that's how we change Z. Okay? What's my problem here? It's probably not a float. Is that my problem? Let's make the UU ones. Let's make this be a float. So type TF there, and here I'm going to type in CF. Right there. Change that divided by a float. Okay? So now we've got doubles, which do you remember how many bytes represent a double?
It's 4, right?
No, that's 8. A float. What do you think a double is?
8.
It's 8. That's right. And a decimal, do you remember how many bytes are in a decimal?
16.
Right, 16. So it's just getting incredibly,
Precise,
exactly. So our UU units are going to all be floats. And now, we've positioned the planet, Earth, Venus, and Mercury, where they go.
Now we just have to fill out the information for everything else.
Yeah, we've created them. Now, here's the problem. I think we're going to run this and we're not going to be able to see them. Because we're not going to be able to move the camera, right, in the game. Well, you know what? We can see them in the other part. Let's run it. Let's actually run it. Freeman 42's out there. Hey, Freeman 42. Welcome. Trying to model the universe here. Doing some Unity and C# coding here on KidzCode. All right. We have an error. Cannot modify the return value of position because it's not a variable. Local position, I think, is what we need to change it to. Is that right? Or is that an old error? I can't tell.
It's not old.
Okay, control space should finish that up for you there. There you go. All right. See if that works. Did it fail? Can you save it a second? Yeah, it is saved.
It is.
Can we go? Wait. Something just changed with a lot of error messages. Let me just look if I may. Okay, there. Save. And what's my problem really? All compiler errors have to be fixed. Return value, transform into position. Each time streamers read the 42x part of my username, I regret adding that to it. But I had to since Freeman was taken on too many services. I bet. Yeah. Okay, Freeman, I won't read the 42x anymore. You've trained me, Freeman. Don't regret it, Freeman. Okay. It's like it's not getting it. This used to be position. We've changed it to local position. I bet even if we comment this out, is it gonna work?
I think this is a restart of Unity.
Yeah, that's what I'm thinking too. Wait, what is this? Yeah, it's the same error. So we're gonna cut it. We're gonna kill it. Go ahead and close it down. Restart it. All good. Just Freeman sounds weird also though. Oh no! Wait, if I can't say Freeman, I can't say Freeman 40. Oh, it's Freeman 42. That's what I'm gonna say. Freeman 42. Sorry, S-O, good O, my God. I'm gonna say Freeman 42. Just call him XD. Just call me him HXD. Oh, it's not gonna work. Did you restart it?
I did.
And we still have the problem?
Yup.
You hit play?
Yeah, it still has the compiler.
And you're just restarting a second time?
Yeah, with Visual Studio this time.
Oh, yeah. Closing down Visual Studio also. Okay. I have a good feeling about this time now. I think this is going to work. Don't forget you've got, notice you've got the Skype window up there. You can close that down on the screen. What?
What?
Oh, you know what? That might have just been saving that error right there. Who's your co-streamer? Oh, that was a Powerpuff Girls joke. You know, I'm not a Powerpuff Girls. Okay, now at least though. Okay, interesting. It didn't keep your changes. Switch it back to local position and see if it works now. Yeah, this is Campbell. Campbell's my son.
Hello.
Calls you my superstar son. He's doing pretty good. Let's see if that works.
No, it didn't save any of the changes. Weird.
Oh, whoa, you know you were at it. No, you don't need to create a new. You hit undo. You had it. The news are already created on lines 14 through 15 and 16. You just need to go planet.average since the sun UU instead of KN. Oh, sorry, and you have to
make it a new
vector 3.
That's what I was doing.
Sorry about that. And it's got to be assigned to local position, not to .z. And vector 3 starts with an uppercase. If you hit control space, it should finish it for you.
And then, wait. So 0, 0.
Good. Oh, and I forgot something else we didn't do. We need to scale it too. So there, get rid of that .z there. So we're assigning just a local position. Let's scale it as well. Mind if I write that code? Because I think Mom's about to walk in and I gotta be done. We got 4 minutes. Is that okay?
3 minutes. Oh, wait.
So I want to get something very similar to this.
Wait, Dad, we're not showing my screen. We're showing your screen.
Ah! Tell me that. Help me, man. That was my fault. I had my eyes over there. Local scale. I want to use the planet's diameter. And I'm going to do the same thing we did before. Diameter UU, we'll create that. Let's go build that in now. So we create a read-only float. So RF, read-only float like that. Then I put a comma after it. I'm going to undo that. Hit a comma right there. And then now I can call this diameter UU. Like that. And by putting a comma means it doesn't give me any backing store. It just gives me this kind of empty getter. And now I can just say, well, let's return diameter divided by 1,000. 1,000F. And type in CF at the beginning to typecast it. Now I've got my diameter UU working right there. Let's jump back to where we were. Diameter UU. And then shift enter and shift enter right there. That gives me all three of those. So now we've got the scale setting up there. Coders, you're chief architect of the Coders Visual Studio Productivity Extension. Yep. Alternative to ReSharper, I am. That's what I do. In fact, we are using CodeRush on here right now. All right, I think we're good. I think we've got create planets, model planets. I say we run it and see if we see them. Don't run it full screen, not maximize full screen, Campbell. Run it and let's look at the hierarchy and see if we see those created objects and see if we maybe move the camera to see them. They won't have the texture. Freeman says, holy blank, that is amazing. Well, thank you, I guess. Trying to do our best. Is it running?
We don't see. Yeah, it is. We don't.
Why aren't they added there? I created the spheres. Oh wait. Can we go back and see where? Oh, do we assign game logic the script to it? I bet we didn't assign the script.
Oh yeah, that's fine.
Now let's try and run it. There they are. Look at the spheres.
Yeah.
We could rename them as well. Let's see if we can find them. See how far they are away from the sun. What is it, a double click or something on it?
Yeah,
how do we get to them? That's not working?
It has the error again now due to floating point precision.
Wasn't there a shortcut like F2 or something like that?
Huh?
It's recommended to bring the world accordance of the game object within a smaller range.
No, that doesn't work on this machine.
It's far away is what, look at that. What's interesting is it's saying up there, it's far away.
Oh.
It's so far away that Unity's like, hey, we just using...
Oh wait, I got this one.
Oh, cool.
I want to try to see the sun from
Now scroll around and see where the sun is.
I don't think we can see it. It's so far away.
It might be on the other side of the planet that way too, I suppose. Oh, wait, we said Z. So it's either going to be down this way or down the other way.
Oh wait, let me just check something really quick.
You want to look down the Z? Oh, wait, no, wait, we know which way it is. The sun's the other way. Because look at the bright side. See the bright? The sun's behind us.
What? It's that way? How far? It's pretty far.
Wait, turn around. I think you didn't turn around far enough. Okay, wait. It's behind us now. So you need to turn 180 degrees around.
Yeah.
Yeah, who's more amazing? Rory's more amazing. Rory's here, a regular co-host here on Tuesday through Thursday. Can I grab the camera and see if we make it? Can you get me close to that thing again? I just want to see if I can turn around and see the sun. Okay, there we are. Oh, cool.
No, you can't.
You can't see it.
That's where the sun is.
It should be somewhere out there.
Yep, it's so far away. Look at its transform on the z-axis. Wait, did we forget to divide by 1,000?
I don't think so.
Oh.
The Z is at 57,000. Let's look at the distance of this. We don't have the name of this.
These are Mercury and Venus, so
they should not be so far away, is kind of what you're saying, right? We would hope to be able to see them. Let's see what we got here. Mercury, distance from the sun. Yeah, it's 57.9. Go click on the third one right there. Click on the last sphere. What we got? Yeah, 57,900. Its actual distance, look at my machine right there, is 57,900,000. We did divide by 1,000, but we are so far away from the sun.
you might want to divide by a million or maybe not.
Divide all the numbers by a million? We could do that.
Or at least like 100,000 first.
We could totally do that. That's what we got. It's not hard to do, but we're at 12 and Mom's about to walk in.
Yeah, we should probably.
It's one of the things we got to watch out for on this show is you don't want Mom coming in trying to stop that show.
Next time we can work on that.
Yeah, we could do it actually. Let me show you how to do that. Let's do it quickly. We're going to come in here. So the scale of the sun, we're dividing by 1,000 again, right?
Yeah.
So the scale of the sun is now going to go to 1 point that. So we're dividing all our factors by 1,000,000 instead of 1,000. So now I've just dropped the sun down by 1,000, right?
We should do Jupiter.
How do we get this again? A double click? I thought with double click would get me in close enough.
Me too.
Am I wrong on that shortcut or no?
No, you're right.
That's tiny. Is there something inside the sun? Or the light pointers in it? Anyway, yeah, I can't see it.
Try double clicking on point light.
On point light?
The one that's in the sun.
Okay. Yeah, it's still trying to pull me back a certain distance from it. That's
Well,
what
then maybe we just divide by 100,000.
Yeah, we could try to do that. I guess I was going to do that. I thought we were going to be able to see it, but that doesn't look like we're going to be able to see it very easily. Normally, we've been able to zoom in on objects that are that big without a problem.
It's
Okay.
still 1 by 1 by 1 and a bit bigger. Like, it totally should be able to work.
All right. So let's take it back to where we were. And then you want to divide it just by 10 more? Or maybe?
Yeah, sure. Let's just move the decimal.
Well, no, we got to do it by 1,000 because we got to get the other one in. Is kind of what we got to do. I'm not sure why we can't zoom in on that. Let's just take it down by 10 here. And we can definitely see that. Even that is like hard to zoom into on that. There we go. Now we're getting closer. Okay. Let's divide it by 10 one more time. See what happens. Can we zoom in more? Now we can zoom in on it.
Which is weird. No.
Yeah, but when I double click though, it like shoots me far away from it.
So far.
That's a little discomforting for me. I wonder if it shouldn't have anything to do with the main camera.
No.
Why would it take me so far away?
No, it should not. No, it should not.
Oh.
Yeah, I'm not liking where it's going. I think what we do is we'll end the show. We'll think about it. Try to work it out better next time is what we'll try to do. All right, cool. Let me just restore that back to where it is. You can kind of save that. What I was going to do is I was going to say, let's divide that by 1,000. And then let's go divide the other numbers by another 1,000. So instead of we're dividing in our UU properties, we change this number here. And that just fixes the scale issue. Yeah, we'll think about that for next time. Interesting. So it's interesting. We kind of came up to some limitations of Unity that kept us from being able to effectively model our solar system.
Making it too big or too far away. Or...
Yeah, kind of interesting. We kind of ran into that. Interesting. Okay, let's go to, let's get a raid going here. And see who's out there. We'll raid you kids. Thanks for joining us today. Sorry we didn't write more code. Normally we'd get more code out there. I'm going to send you over to Clarkio. What's Clarkio doing? Let's see. Be sure. Is he writing some code over there?
Okay. Thank you for checking out Win of the Week. Layla's raiding now too. We're going to have to scale up.
All right, we're doing a raid. We're going to go get a raid, get them with our raid. Everybody going to go raid Clarkio. Thanks again for hanging out with us, kids, and we will see you
tomorrow
on Hey, the volume is so tough for me to hear you. Also, so I want you to focus on that.